Okay, the class tonight is going to be on getting data in a broad sense. So we will walk through what getting knowledge from the data can be, and where and how we can get data for our analysis. So let me start with the presentation. So extracting knowledge from data is something that is normally called data mining. So the students of my 623 class know quite well what data mining can be. And what we will do tonight will be a little bit going through some of the slides on data mining and use those concepts for what we need to do for the rest of this course. So data mining is basically extracting knowledge somehow from data. So mine for knowledge in eventually vast and or disorganized collection of data. There are several definitions for data mining. Process used by companies to turn raw data into useful information. That's very generic. Practice of searching through large amount of computerized data to find useful patterns or trends. And that seems to be more actionable definition. And we will use probably this one the most. There are several applications for data mining. So obviously in all the areas where you have a lot of data, you can apply data mining. So it can be either commercial uses, scientific uses. All of those are good candidates as domain for data mining. Data mining is basically a sort of a crossroad of several different disciplines. So you have some statistics because you want to know more about your data. Database technologies because they reside somewhere in data structures that can be databases or can be other structures, but you need to know how to deal with that. Machine learning because you want to apply algorithms to create models to extract the data. And all of those will be somehow powered by information science, because at the very end you will write or use computer programs to manage the information, the data that you collected along the way. And then once you have your metrics, your data extracted, you may want to visualize them in a proper way, because images are a more powerful way to communicate data structures in a broad sense, or data-based results. Other disciplines, because sometimes when you create a model, you may want to have different points of view. So you may, if you are analyzing data that are related to people, you may want to have components from sociology, maybe anthropology, to better understand how people is doing things. So it's definitely a multi-disciplinary environment. So in data mining, we use a lot of different competencies. There are challenges, size and quality for sure. Size because you may have a huge amount of data. You may have data sets that are several terabytes, and you want to extract a sense, meaning that you need to manage it somehow. Quality, because at the very end, quality matters, because if you have a data set with a lot of data, but they are not reliable for any reason, results will be not reliable as well. Obviously, when you have very large data sets, you may be more tolerant in terms of quality of the data, but nevertheless, you really want to be sure that the quality is the best you can get. There are differences between data mining and statistical analysis. We mentioned the fact that in data mining we use statistics, but it's not equivalent. It's not data mining equal statistics. So in statistical analysis, somehow you already have a structure. So you just want to extract the results. So generally speaking, statistical analysis is deductive. So you have data and you extract the information and you're good to go. That can be for budgeting reasons, for business planning. So all of those, you already know the kind of data that you will get. In data mining, not so much. You have a bunch of data and you do not know exactly what you are going to get. So it's more an inductive process. So you extract from the data the knowledge that you want to get. So is the data, is the data points representing different views of the same event that we want to analyze or recreate or understand. The data points will give you the sense of what is inside. So it's inductive and not deductive as in statistical analysis. Number of data is growing quite a lot. So you have a huge growth of data, and you have a relatively low number of analysts. So there is a gap, leaving a lot of nice, interesting possibilities for data miners. There are a lot of tools that can help people even without a formal education in data mining, but nevertheless, if you want to do things in a more effective way, you need a formal training. So, big data. This is something everybody was and is talking about. Big data is a very generic definition with not much structure in the definition. So generally speaking, you talk about big data when you have huge quantity of data, changing in time quite a lot. So you have variety, velocity. So those are some of the characteristics that are generally considered as key characteristics for big data. Not necessarily big data is social media. So just as an example, most of the modern complex engines, they have a huge amount of sensors. So those sensors are collecting data over time, generating an incredible amount of data. So at the end of the period of use of the engine, you have a lot of data that is not social at all, but can definitely be considered big data. So, and you need to apply all the big data approach to get a sense out of that. Applications, there are several applications in different fields. So human resources, there seems to be something that is kind of out of the main line of data mining. But if you consider that you may be a company with several thousands of employees in different places around the world, like a huge consulting conglomerate, and you may want to aggregate teams based on proper characteristics. You want to minimize the cost for the company. You want to have as much coverage of the skills that are required in that particular assignment. You want to you want the team to be as much compatible as possible, both with the environment they are going to go. There may be cultural, religion issues, and within themselves. So all of those create a sort of pattern, sort of strict conditions for assembling the team. So modern or more structured consulting companies are creating systems to scan communication in the company, and based on communication and information about past projects, they assemble the team. So this modeling is a way to apply the concept of data mining to human resources. And then there are other areas that are kind of obvious, marketing and sales, so profiling individuals to deliver the commercial messages the best we can, the mythological one-to-one marketing that was a sort of a mantra for marketers years ago now is kind of there. I mean, we realize how intrusive that can be, but at the very end, we are basically there. I mean, companies like Facebook are literally reading our navigation behavior, and based on that, they deliver commercial information or ads. So, marketing and sales, quite obvious. I mean, if you want to do something like that, you basically need to classify the advertisers with proper tags, and you need to classify your readers or clients, whomever you are, or people on Facebook. And then you need to create an engine to match the two components. So this matching business is basically what is driving the internet commerce in a broad sense today. Then you can be Match.com, that obviously is matching people, but you can also be Netflix, matching viewers with the videos that you have, the content that you have. You can be Uber, matching potential passengers with destinations and drivers. I mean, all of them are based on the paradigm of matching. Matching is data mining, is machine learning and modeling and predictive analytics in a broad sense. Which kind of data we are going to mine? So relational databases, data warehouse, all of those are sort of traditional ones. So most of the data boom that we described in the first slides are more on what is not so structured. It's more on web, text, multimedia, all of those is the kind of data that are generating the most of the traffic today. A dataset we all know that in the very basic example is composed is a table-like. So it's composed by rows that are data points and columns that are values of attributes. So you have one data point with those attributes. Those attributes can also be called variables. So those variables may have standard values, meaning giving information about the basic characteristics for that data point, or can be with special meaning, like in this case. This is an example for tax purposes. So tax ID from 1 to 10. Then the attributes for each tax ID, meaning each individual, is refund yes or no, marital status, single, married, divorced, taxable income, and then if this individual is cheating or not on the tax return. So basically in this case you have 10 different data points. You have 4 attributes or variables. One of them can be considered special because it's the one who that classify somehow the data point. So we can assume, for example, that we want to use this sort of experience to determine if someone will cheat or not on taxes. So if, let's say, if you look at married individuals, so they are always no. So we can say that probably if marital status is married, then will not cheat. If is divorced, there are 2 cases. We can say divorce with high taxable income is not cheating. So we need to create a sort of a model predicting, is a predictive analytics. So it's a model predicting the outcome, meaning if someone with a given refund status, a given marital status, and given taxable income is going to cheat or not. So based on this experience that is on those 10 cases, we can define if we can create a model that will help us decide if this subject will cheat or not on taxes. Obviously, no one would use any model based on 10 cases, but it's just an example. So we already described what the values can be. So which kind of type of values we can have? We can have categorical or numerical, basically. Categorical meaning qualitative type, gender, eye color, genre. Numerical that can be qualitative but is typically quantitative. So can be ranking, grades, height. So those are numerical. We can have numbers defining those attributes. And then we can have special cases of either categorical or numerical, like intervals or ratio. We can have documents that are, or files that are quite different, like in this case we have a document. So document where we have a bunch of, sets of documents. We have a bunch of documents, and like in this matrix, each document has a different words. We can say that the word team appears 3 times in document 1 and 0 in the other. Let's say lost 2 times in document 1, 3 in document 2, and 0 in document 3, and so on. So when we use something like that, we use something like that, for example, when we want to detect plagiarism in text or cheating in submissions in academy. So we basically compare 2 different documents and we calculate the number of words that they have in common. Then if they have a large number of words in common, and we can define case by case what is large, then we do a second step that is basically evaluating the number of times the words appearing in both the documents, they appear in the same position. So if you have a large number of words that are the same and appear in the same position, and again, large number is something, how large, the number for large is something that we can define case by case. If we have a large number of words appearing in the same positions, then we can say we have a case of plagiarism, or those 2 students cheated. So that's an application. Transaction data. So in this case, TID is transaction identification from 1 to 5. It's basically what people bought at a store. So subject, the first subject, the first transaction, we do not know if different subjects or different, or just different transactions, for sure, different transactions. So transaction 1, you can imagine this like a basket. So the first basket contained bread, Coke, milk. Number 5, Coke, diaper, and milk. So this is another example, transaction data. Graph data, it's another something that we can get when we collect data. So this case is a political debate. We have this guy checking the facts that the politicians were saying. So it's quite popular. So this is a relational network. We have people related one to the other. This one is another example, is a Facebook network. I mean, right now, Facebook does not allow people to download their own friends network. This was a few years ago. You have this sort of islands. It's my Facebook network. So I lived in different places in the world and I did different things. So basically each time I developed friendships. So you can see this one. In this case is my professional island. This could be my runners community or other. And you have some individuals that seems to be more relevant. So the way to measure this relevant position is called the betweenness centrality, and is the measurements of how crucial is a node for the network, meaning if I remove a network with a very high betweenness centrality, the network will not stay as a single network. So if I remove this node, the pieces will sort of fall apart. So again, I mentioned this my Facebook network. Those are islands of people in different places or activities. This node is my wife, so we are together since 30 years and she knows everyone or almost everyone in my network. Don't ask who this guy can be or person can be, because I sincerely don't remember. So data mining is not just I apply one technique to a data set and I will get result. is more of a process. So there are phases in the process. This is the most commonly used methodology for extracting data from data sources. So you start with defining what you are looking for. So if you are looking for, I don't know, who is the most influential person in my network, or how can I assemble the right team for my new consulting job in Singapore. So business understanding is defining the business question. Then you need to go to see if you have the data to answer the business question. So basically this is a back and forth because you may not have the right data to address your business question. So you need to assess the data that you have, and eventually you need to go back and adjust somehow the question that you have. Then you need to prepare the data, because most of the time the data sources are never clean, are never ideal. There are always quite sometimes a lot of work to do on the data. If you have different sources, you want to put together the different sources. You may want to normalize data somehow. You may want to address the issue of missing values or synonyms with different spelling, maybe like address. You can have street, the full word. You can have s dot, st dot, str dot. So all of those, if you want to do any analysis, they needs to be the same. So this is in the realm of data preparation. So once you have the data in the proper shape, then you do the modeling. So meaning you apply an algorithm to create the model. Once you have the model, then you want to evaluate it. So you want to be sure that the quality of the model is good enough. There are techniques for the evaluation. If the result is not good enough, you may want to go back to any one of the other phases and to do some adjustments. When you are happy with the results that you have, then you will deploy the model to your final environment, whatever it is. So there are 6 phases in a standard data mining methodology, and they are all important. Some will require more time. Data preparation, the books say that between 70 and 80% of the total time of the project. And by experience, I can say that is quite right. So again, we need to focus quite a lot on the quality of the data, because the quality of the data will be essential to define the quality of the analysis. When you get the data from different sources, you want to be sure that you will follow all the good rules for privacy and copyright. So 2 different things. So when you are working on data that somehow can be impacted by copyright, you need to be sure that the copyright is addressed in the proper way. So there are different levels of protections that you may have. So some data are available to everybody. The web data, by definition, if they are there, they are accessible, unless there is a password protection. That's a different story. But if there is no protection, then it's open to everybody. Social network data It depends. There are some information on social media that are available to everybody, other that are restricted to members of the community. If the whatever is the community, it can be LinkedIn, it can be Facebook. Um, some social media are open. Twitter, there is no limitation. You not need to follow someone to download their tweets. Tweets are considered microblogs. Microblogs, like blogs, are open, like web pages. Other one-to-many, so you have some data that are proprietary, but they are released to some people by contract. So they have a contract. One individual is giving information to a group of other individuals according to their own contract. Or you can have a very strict one-to-one access to data when you have confidential data. Your healthcare information, probably they are protected by a confidential agreement between you and your medical doctor. And then there are open data. Open data are freely available to everyone for using. So there is a sort of universe. Most of the time, the origin of those open data set is government. So governments from different places around the world, they make some of their data available either by law or because they want to be clear and transparent. So this is an actual example of some of the open data that you can get from the web. It's basically the same in scientific information. There are researches that are fully open, others that are restricted. When you publish something, you can decide if you want to give the publisher the rights to distribute the paper, or you can have open access, and at that point everybody can access it. Most of the time, if it's in open access mode, then the author or the authors, they have to pay something to cover the expenses of the publisher. Most of the papers are not in open access. Some examples, federal government. So if you go to data.gov, you will get a lot of data sets. UK, they have a similar initiative, data.gov.uk. Australia, data.gov.au. If you go to this website, we will go in a second, you will get, we can go right away actually. So this website is a Google website I created and I'm using for EM623. That is a data mining course. So you are going to have, clicking one of those, you will go to an external website with either one specific data set or a bunch of data sets. So Amazon, they have public data sets. Kaggle is interesting, is a website with several information for data miners, including data competitions, so data contests. So basically companies, they publish those data contests, they provide their own data. Most of the time they are sanitized some way, and they ask participants to submit their own solution for the specific mining problem. One of the cases that is most commonly cited is Netflix. They published the selections of movies of their clients, and they wanted to have a predictive model to propose new movies to clients. So if you like your customized selection, suggested movies, something like that. If you are a Netflix user, you know that it never worked, but the price was $1 million, and they did something that is better than nothing, but it's not exactly very effective. So you can definitely go there and either be involved in this data mining community and trying to address some of the issues in the data competitions, or you can just go there and download the data set. So let me go back to the presentation. And so data sets, you can put together different data sets from the web, creating your own data set that you can use for whatever is the application that you have in mind. So basically in those cases you have data sets or information residing in the server. You can write a code, or you can use your browser to go to that server, eventually being authorized with a sort of authentication, and download the data that you need. And then you can take this data and combine with other sources and create your application. This is called mashup. The servers, they have to be compliant to a sort of a standard. They provide web services. An example that is no more in business, but is very indicative of the way to do those things. There's housemaps.com is basically putting together information from Craigslist and Google Maps. Basically on Craigslist is taking the ads on the apartments, and then they map those apartments on Google Maps. So you have in one single application the place of the apartments, so the locations of the apartments, and their characteristics. So this is an example of a mashup. When you do mashups, you need again servers able to let you go in and download the information that you need, providing what is called a web service. That is a method of communication between electronic devices, a software system designed to support interoperable machine-to-machine interaction over the web. So those are two definitions. Concept, it's pretty clear. So when you connect to systems, they need to speak some sort of the same language. Same language in terms of connection, in terms of standard of data sets they exchange, and in terms of languages for requesting the information. So these languages are or statements creating a sort of script program. Those are application program interfaces, APIs. APIs are sets of statements that the source of information makes available to people who want to access their websites or website. So API, there are APIs for Twitter, for Amazon, for Facebook, LinkedIn, and so on. They're obviously not the same. Each one can grant you access to some of the information and not other. It depends on their policies. And then you use HTTP for the communication. That is the same protocol that is used by your browser. And you use either HTML or JSON for the data exchange. So the format of the files going back and forth between those servers is either XML or JSON. Right now it's more JSON than XML. So Twitter, just as an example, they have their own APIs. Through the API, the Twitter API, you can download single tweets, streams of tweets, tweets with a given keyword, and so on. So just as an example, so you can do basically with the get, you can get basically something similar to what you get from Google when you do a Google search. So you will do a search for tweets with given characteristics. So that's basically it. The main reason for this whole class is to introduce you the let's say the final exercise for this course. That is basically creating your own exercise, meaning that you are going to select your own data set, and you are going to create your own analysis on that data set. So there are two components. One component is the search for the data set. You do not want a data set that is too small, because otherwise it wouldn't make any sense to do any effort in creating a program to analyze that and then create a report describing the results. So you need to find a data set that is big enough and worth the effort of doing the whole process. And then you will do an analysis. So the analysis will have the core component that will be a Python script that you will write, and just like we did in recent exercises, you will write a report describing the goal that you had. So you will describe similarly to what you did for the comparison between different texts. So you will describe what you are going to do and what you found. And you will add in your report your tables, graphs, things like that. So in this case, we have a sort of a preliminary stage. So the preliminary stage is basically the exercise that you will do for the next class. And basically the exercise is describing what you are going to do in terms of data set and analysis. So you will find a data set that would be appropriate for the data analysis project. Eventually you can change it if after the following week you change your mind and you decided that you want to do something different. You can do it, but obviously then you need to go back to doing again what you already did, or you can stay with the same data set that you used for exercise number 9. So then in a Word file, you will write your name, the URL where the dataset is. So be aware that it's not going to be just the main directory, but the real URL for the specific dataset. So if is data.gov, the URL is not going to be just data.gov, but the pointer to the specific dataset. So URL, description of the dataset, description of the analysis that you want to do on the dataset. Then you want to describe what is the source of the data, the type of the data items, meaning brief description, they are transactions, they are images, is a text, is numbers, whatever it is. And then you want to add some records from the dataset. So you will create a script, checkfile.py, to count the lines and print the first 5 lines. So you will create the script, you will run the script, and you will add to the report the first 5 lines and the number of lines or data points in your dataset. And then you will submit both the Word file and the Python script. Assignments are individual, so no group assignment. Different students can use the same dataset, but they need to do different analysis on this dataset. In order to proceed with the final project, you need to be approved by the teacher, by me, on the combination dataset analysis. Permission will be granted on first come, first serve principle. So if 2 students are proposing the same analysis on the same dataset, the first one will get the okay to proceed, and the second one will be forced to search a new dataset or propose a different analysis. If the proposal will be refused, you need to submit a different one. So suggestion, do it as soon as you can, and be as much creative as possible to have more chances to be unique. So that's basically it. As usual, if you have any question, email me or meet me at Babio, and I will be more than happy to do my best to address your issues. Thank you and good night.